everyone. My name is Phoebe, the member of RunSpace organizing team. I'm absolutely thrilled to announce that the RunSpace Innovation Challenge 2026 is now officially open for registration. This competition is organized by the Industrial Development Administration, IDA, and executive organized by the Institute for Information Industry, III. We are also honored to have the Lunar Infrastructure and Transportation Company, iSpace, as our strategic partner of this year, alongside an incredible lineup of supporting partners including Ariane Group, Arcatch Space, Astronis, Loft Orbital, and NovaSpace. Today, I will guide you through the details of this year's challenge and how you can be part of it. Now, let's start it by looking at the bigger picture of why we are here. RunSpace is more than just a competition. It is a space-themed innovation ecosystem based in Taiwan. Our goal is to foster global partnership and discover breakthrough space solutions. We aim to connect the boundless creativity of talent worldwide with the practical needs of the space industry. As we celebrate our fifth anniversary this year, we continue to bridge the gap between visionary ideas and real-world implementation, helping teams turning their concept into tangible impact. To understand how we can achieve this, let's introduce the team behind the initiative. The Industrial Development Administration IDA plans and coordinates industrial policies and international partnership for sustainable growth, ensuring that Taiwan remains a key player in the global supply chain. And we are from the Institute for Information Industry, or III. As the executive organizer and a leading think tank, we drive digital transformation and smart technology adoptions. Our role is to provide the necessary support, resources, and networking to help your projects reach new heights in the new space economy. Looking back to the journey since 2022, RunSpace has been a platform for incredible talent and creativity. In our early years, we focused on igniting interest in satellite applications and exploring the possibility of space data. As we progressed, we saw a growing emphasis on hardware-software integrations and cross-border collaboration. Each year, we've seen teams pushes the boundaries of what's possible in space technology. While every team's path is unique, our goal mission remains the same. We build strong connections between our participants and the space industry, guiding them to understand the latest market trend and meet key industry players. This industry connections is reflected in the diverse group we attract every year. The impact of RunSpace is truly global. In 2025 alone, we attracted over 80 teams and 200 participants, representing 28 different nationalities. It's truly global. In 2025 alone, we attracted over 80 teams and 200 participants, representing 28 different nationalities. This diversity is what makes our community so vibrant. We've seen teams combining expertise from engineering, data science, and business to tackle complex space challenges. Whether you are a local startup or an international research group or students from the university around the world, this is the stage where your voice can be heard by global industry leaders. Beyond the competition itself, we are committed to providing the right support for your growth. We don't just host a contest, we provide a journey of development. Last year's participants benefited from comprehensive pre-competition training and intensive shortlist boot camps. These programs are designed to help teams refine their business model and technical feasibility. By connected with global experts, teams can explore real business opportunities in the LEO satellite sectors and learn how to navigate the complexity of the space market. Speaking of the success stories, let's look at the teams that stood out last year. To celebrate the hard work and innovation of our participants, each year we held an award ceremony. It was a fantastic event where we invited our top teams to take the stage and share their winning proposal with the industry. Seeing these ideas presented to a professional audience is always a highlight of RunSpace journey. Now, let's take a closer look at the specific projects that won in the implementation category last year. Our 2025 winners demonstrated exceptional creativity. First place went to AstaSense for their Space Canary project, which uses engineered microbes for radiation detections. MetaView took second place with their customized meta service design, showcasing high technical excellence. Taipei Lear Lasercom took third place with their sophisticated laser beam alignment system. These teams set a high bar for innovations, and we are excited to see who will follow in their footsteps in this year. If you are wondering how to get started for 2026, here's the timeline you need to know. Please take notes of these important dates. Registration is open right now and will close on June 30th at 1 p.m. Taiwan time. We encourage you to complete your submissions early to avoid the last-minute rush. Before the submission portal closes, you can always log in and fine-tune your proposal as many times as you want. Another key date is May 11th, when we will hold our pre-competition training, which we will have a slide to introduce the event later in this video. After the registration deadline, shortlist will be announced in August, followed by an intensive boot camp in September to prepare the finalists for the final award ceremony in October. Okay, now that you know the when, let's talk about the what in this year's themes. Our themes cover the entire space value chain. First includes the ground equipment and service, which focuses on antennas and user terminals. Satellite services, including the edge computing, image recognition, and IoT. The next, satellite manufacturing, is looking for innovative components and subsystems. Satellite launch, addressing deployments and orbital logistics. We also welcome AI-powered solutions, space debris removal, and space agricultural, etc., under our others categories. So if your ideas can contribute to the future of space, we want to see it. For 2026, we have 2 tracks in total. First, implementation categories. This is a global call for innovations open to teams of 2 to 8 members. We are looking for projects that demonstrate technical viability and clear market potential. For these categories, your submissions must include a visualized project. This could be a 3D model, a functional prototype, a digital dashboard, or even your technical code. The goal is to show how your ideas works in practice. The second track is the Sponsor Special Topic, or SST. The track is centered around a written proposal to solve a specific challenge defined by our industrial partners, iSpace, focusing on lunar mission. Unlike the implementation categories, a physical prototype is not required for the sponsor special topic. And later in this video, a representative from iSpace will join us to provide a detailed instructions to the sponsor special topic requirements and their vision for lunar exploration. Next, let's talk about the price. For the implementation categories, the first place team will receive a 350,000 NTD dollars. We will also have significant cash prizes for second and third place, and a bonus prize for all 15 finalist teams. For the sponsor special topic of iSpace, the winning team will receive a 20,000 NTD dollars, and beyond the cash, iSpace is offering a group mentorship sessions and an exclusive Tokyo headquarters visit and pitch. This includes a facility tour and a session with their technical team leads. Please note that the Tokyo visit is on a self-funded basis, but the networking value is immense. To help you prepare your proposal, we also have a special event coming up. On May 11th, we are hosting an online event, the New Space Economy. You will hear from the panel of international experts, including Jun Kuramoto from Arcatch Space, Yurish Kotiks from Ariane Group, and Blaine Cristillo from Nova Space. They will share deep insights into Asia-Pacific trends and the European ecosystem. This event is a must-attend for anyone looking to understand the global space market, and you can sign up now via the QR code. We are nearing the end of our briefing for the RunSpace 2026, but it's time to take your ideas to the stars. Join us in fueling the race to space innovations, and we are looking for the next big breakthrough, and it could come from you. Let's push the boundaries of what's possible together. You can scan the QR codes on the screen to visit our website or follow us on LinkedIn for the latest updates. If you have any questions at all, please feel free to reach out to the organizing team, and we are here to support you throughout the competitions. Thank you for watching, and we look forward to seeing your submissions. Now, I will hand it over to the iSpace representative for the sponsor special topic briefing.
Hello, everyone. I'm Antonio Stark. I'm currently the Global Alliance Lead at iSpace, which is a lunar infrastructure and transportation company headquartered out of Japan. We're really excited to be a sponsor for this year's RunSpace competition. And let me just give you a quick introduction of iSpace. So iSpace is a company that is really targeting the cislunar economy. Cislunar economy basically means economy around the moon. And we're going to the moon because space is fun, space is exciting, but also at the same time, space has a large amount of resources that we are interested in, specifically for the moon. That includes very low gravity, 1/6 of Earth's gravity, as well as water ice that is currently collected and stored in the polar regions of the moon over the last millions and billions of years. We want to go there to mine those water ice and then utilize it for various purposes such as drinking water, split it into oxygen and hydrogen that we can use for astronauts as well as rocket fuel. For iSpace ourselves, we have been founded in 2010 out of Tokyo in Japan, and we now have subsidiaries in Denver, Colorado in the United States, as well as Luxembourg and in the European region. This is a quick photo of our Japan team. So you can see me over on this side of the screen next to our CEO. That was also our photo using the resilience lander that we have done for our mission last year, which you will see the following slides. That is a quick team photo of our US office. So again, this is in Colorado. We have a whole hangar dedicated to our operations, which is really cool to see, as well as our Luxembourg office team that is really more for making the lunar rovers. And you can see here that they have their lunar rover that we have sent on our last mission, the prototype of that rover, along with our lunar yard, which is our kind of lunar environment or lunar surface prototyping facility. So for a quick recap of the missions at iSpace that we have done in the past. So our first mission was actually launched very, very early on in 2022. So this is when we became the first commercial company to launch a lunar lander. So a lot of companies are there right now trying to do missions for the moon, but we were the first to do that back in 2022. We had a bunch of different payload customers that were going with us, including the MBRSC Center from UAE. So we did the launch in late 2022, and then we attempted a landing in early 2023. Our next mission came in 2025. So we launched in very early 2025, and then we attempted a landing in mid 2025. And at this time, we also had our own rover that you saw in the photo called Tenacious, which was supposed to go around the lunar surface and collect lunar regolith for analysis. Unfortunately, both of our missions had a hard landing at the very end, which means that the lander unfortunately made a hard contact on the lunar surface instead of a soft landing. But we had a lot of different steps going up to that stage that were successful that I can quickly recap with photos. So on January 12th, 2025, we had a successful integration of our lander on top of our launch service provider, which was SpaceX. So we launched on top of Falcon 9 rocket from SpaceX. We had a successful launch. We had a successful deployment of the lander. So the yellow thing that you see on the screen, that is actually the lander that is being deployed from the canister deployer module that you see on the lower side of the screen. We made successful contact with the lander and operation. That is the our mission control center that you see in the screen there, as well as our CEO doing a really good cheers. And this is a photo that we took of Earth as we were orbiting the Earth and leaving the Earth. So getting to the moon is very difficult. So space is an incredible space, and you can have a bunch of satellites that are orbiting the Earth right now, but getting from Earth orbit all the way to the moon is a really, really difficult process. And how we do it is that we orbit the Earth a few times just to make sure that all our hardware, all of our communication, all of our payloads are operating fine. And after we do a few orbits, then we do a few burns to kind of increase our orbital altitude. So and with the Earth being here, we have an ecliptic orbit, and then we keep on boosting, and we keep on going farther and farther away from Earth at our farthest point. And while we're doing that, we get to take this really, really nice photo of Earth. And at the highest point, then we make a burn that will actually then get us on an orbit called a TLI, or translunar injection orbit, that's gonna send us shooting off to the moon. And when we are arriving to the moon, this is when we take that photo on February 15th on Resilience while we are conducting a lunar flyby. So a lunar flyby is when we are just reaching the moon. We're not orbiting the moon yet. We are just reaching the moon from that kind of shooting from Earth. We reach the moon and we use their moon gravity to kind of to capture us into lunar orbit. So this is our first pass of the moon, and then we are then slowly circularizing into a smaller and smaller orbit around the moon. So while we do that, we go around the moon, around the Earth. So again, this was after we do the lunar flyby, we come back to Earth for one last time. So this is our goodbye Earth photo taken on February 18th. And then as we circularize and lower our orbit from the moon, we get to see more details from the lunar surface. So this is the photo that we took of the lunar craters as we are lowering our altitude. And this is also the photo of Earthrise that we took from our lander on May 27th, 2025, before a few, like right before we were making our landing. And then we were attempting the landing, but due to a sensor malfunction, we could not get our boosters up in time. So unfortunately, we could not slow down fast enough to make a soft landing. So that's when we made hard contact with the lunar surface. But that doesn't mean that we have no other missions going to the moon. So the lander that you saw in the previous photos, that was using our resilience lander. So that is the first lander prototype that we developed. It's a very small lander with about 30 kilograms of payload space. Our next lander that we'll be using for our future missions is called Ultra. So this is a much, much bigger lander, almost more like close to like 10 times the payload space from our earlier resilience landers. Of course, payload space kind of depending on like what we're going to send to lunar orbit and what we're going to send to lunar surface. But we're really excited for this lander to actually take shape. And we have missions coming up from 2028 to onward. So again, this whole competition, we want you to come up with ideas on how, what you think, what kind of payload ideas, experiments, scientific sensors, or even fun things that you think will be valuable for the moon and for humanity here on Earth. We want your ideas, and these are the missions that we can potentially, if successful, be on. So again, our next mission will be in 2028. We have another mission coming up on 2029, as well as in 2030. So this is our kind of quick mission roadmap. You can see here our lunar lander is called Ultra. We also have other missions, including lunar satellites. So of course, even in next year, 2027, we have a satellite that we're launching with a partner from the US called Argo Space Corps. And in 2028, I think you see on our past photo, we have a bay for our satellite deployment up on top. So that bay will be used to deploy one of our own satellites to lunar orbit, and then we'll keep on doing that for 2029, 2030 as well. We also have a different spacecraft called an orbital transfer vehicle that we're also currently in development, but right now we're going to focus on the lander because that's where we want you to develop and give us your ideas on what we can do on the lunar surface or on the lunar orbit. If you have ideas for lunar orbit, we can also send it on lunar orbit as well. Quick overview on the mission 3, our next mission that we're going on. This is going to be on 2028. Scheduled launch. We already have payloads from Japan, from Institute of Science Tokyo, that was funded by the JAXA Space Strategy Fund, as well as a payload from Taiwan, dedicated by Taiwan Space Agency. We actually have 2 payloads coming from Taiwan called Flute and LVM, and you can look them up if you're curious. We also have a rover payload that is coming from Korea as well. So it's a little 2-wheel rover that's gonna go around the lunar surface. So quick specifications on the lander itself. So of course we have more questions. We'll have a Q&A time, but this is a kind of quick overview of the lander itself. So the lander is about 3 meters, 3 meters, 3 meters in size. So if you imagine a 3 meter, 3 meter, 3 meter cube, it's slightly bigger than that. If you include the landing legs. And then the lander itself does everything from what the rocket does, the rocket gets us into Earth orbit. And then the lander uses its own fuel and own thrusters to actually leave Earth and then get to the moon, orbit the moon, and then make the landing. So all that is done by our lander. It also does the power generation. So it has solar panels so that during lunar orbit, as including getting to the moon, during lunar orbit, and on the lunar surface, it can generate its own power and then give it to the payload. So again, the payload that you have, you don't necessarily need to generate your own power. You can just take the power from us. We'll give you the power. We also do the communication. So the lander is equipped with its own antennas, and we also operate our own ground stations with our partners. So the ground station provider from our partner, we operate through them, and then we do our own communications relay. So whatever payload that you have, you don't need to have your own antennas, etc. Just give us, just say, hey, this is the things that you're gonna do. This is the kind of information that you're gonna collect, and then we'll figure out how to collect the data from the payload, take it to the lander, and then send it over to Earth. It may be real time, it may not be real time, depending on the requirements of the payload. Quick view on where your ideas would go on this big lander. So we have a bunch of different payload bays on the lander itself. Again, it's a very, very big lander, multiple locations. What we want you to look at is the lower bay. So this yellow boxes on the low side. So there we have 8 total, 8U bays. And what 8U means, it's kind of like, this comes from CubeSat language. So CubeSat is small satellites, and 1U is a cube that is 10 centimeter, 10 centimeter, 10 centimeter. And the yellow box you see there is an 8U, which means it is 2U, 2U, 2U in size, or 20 centimeter, 20 centimeter, 20 centimeter in size. So each of that yellow box, each of its dimensions is 20 centimeters. So whatever ideas that you want to give us, you can put it inside an 8U or a 20 centimeter cube, and we'll figure out how to connect it to the lunar lander for power, for thermal, for electrical controls, for data transmissions, all that. What we need from you is to kind of figure out, give us your ideas on what you think will be valuable for the moon. Like, are you trying to kind of put a camera? Is there any kind of spectrums that you think you'd be interested in to learning about? Are you going to put a magnetometer, any magnetic spectrums that you're interested in? Do you want to actually deploy something? Do you want to maybe drop something onto the lunar surface and then kind of see if there's any dirt or any substance that you want to collect? Is there any chemistry or any biology experience? You want to take any biology, like any bacteria or any living organism that you want to see happening, or any chemical reactions that you want to see on the lunar surface. All that is possible. We're here to really hear about your ideas on what you think would be interesting to see on the moon, and what are the scientific or commercial values that will have for us here on Earth. So what can we learn from that experiment? So that is a quick recap of our lander and the missions that we have going forward. This is again quick a quick recap on the payload itself. The total mass should be around 4 kilograms or below, but depending on the payload, we can be a bit flexible in the mass. And that's it. So thank you so much. This depends on whether the payload will be deployed from the lander or not. So if it's going to stay on the lander, so if it's just a camera, if it's just a sensor that's gonna stay on the lander for the whole time, then yes, we will give you the power. I mean, the lander has its own battery and solar cell, so it'll collect its own power, and we can provide you with the power. At the same time, if the teams want to do any deployment, so again, the idea is for lunar surface or lunar orbit. So if you want to actually make a satellite, an 8U satellite, and deploy it from the bay, that's also possible. If you want to make a little rover or a little sensor that's gonna drop down from the lander, and it's not necessarily tethered with a wire, then in that case, that needs to have its own power because it's separated from the lander. So as long as it's connected to the lander, we can provide the power and the communication. If it becomes separated from the lander, then we need a way to do the power and communication, data transmission separately, that is wirelessly. Everything included. So our ideal range would, again, as you saw on the slide, is actually 4 kilograms. So 4 kilograms is where we can comfortably accommodate an 8U payload. If we could stretch it to 5 kilograms, if you have anything else. But usually for an 8U, it's hard for you to try to exceed 5 kilograms in an 8U package anyway, so we don't necessarily think that will be a problem. But yes, everything included would generally need to be around 4 kilograms or lower, and a maximum of 5 kilogram. It'll be a plus point. So it is not an absolute requirement, because a lot of the times, even for our government missions, they sometimes don't really know how much that data that they will capture. Because a lot of the times we look at the data, and then we have a sample of the data, and then they look at it and they figure out, hey, this is valuable enough, and then they want the full data for that time, etc. So it depends on mission by mission. Preferably, you won't be having to transmit live data all the time. And in that case, the best case is if you're just like collecting some sensor. Like you basically have a sensor, you detect it, you store the data, and then we'll just have that over in our data bank, and then we'll transmit it when we have a good communication window. We'll just download it all at once. So a live data transmission is quite hard. It's also quite expensive. A stored data cache and then sending it back to Earth is going to be a lot easier. But again, this is really, really looking at just really interesting ideas. So contestants don't need to think too hard on the data side. We want to look more on the hardware side. So data and operation is a good plus point. But if you have no idea how much data that you're going to have, that's also fine. You don't need to go into that much detail yet. I would think so. Yes, I think again we'll have our own judges, and the judges will think more favorably if you can tick off multiple things. So again, the objectives are different. Like sometimes it is just scientifically valuable. You just realize something about the moon, about the lunar surface, the characteristics of lunar dirt, for example, and that's just scientifically important. Like oh, we didn't know the lunar dirt was going to have these kind of chemistry or these kind of physical properties. That's nice. That's new information for humanity. At the same time, if that is also commercially helpful, like for example, if that allows us to actually see, hey, we can do something interesting with that lunar dirt that is going to make us allow us to make lunar bricks, or that is going to be utilized for ISRU, which is in situ resource utilization, and then that has a commercial value. Then it becomes just a knowledge that is good to have, to a knowledge that is important for us to actually make things on the moon and make money, which is commercial value. In Or you can say, hey, we want to see how this semiconductor or this chip or will work in space, in the moon. And we figure it out and we say, oh, this chip works out. So this chip is now valid for more industrial applications. So this particular piece of hardware, it now can survive in more extreme environments here on Earth. But also, if that has a more space aspect, now we can utilize the chip for future lunar missions as well, or other customers. That is a big value. So the more valuable the payload is, your idea is for more people, that would be a good plus that'll be looked favorably by our judges.
Okay.
Right. This is more real life criteria. So a lot of times, good ideas, there are, even at NASA, like thousands and millions of good ideas are there, but it doesn't get funded. And then the idea never flies. So the reason that we put that criteria in there is kind of see how realistic. So a lot of times we understand that an idea itself is valuable, but it also needs to be valuable for other people. Especially if it can be your local organization, your local space agency, your local government, or office, then it makes sense that government is just kind of enhancing the pool of stakeholders who will benefit from that payload, and saying that, hey, this idea is good, and we now have more organizations who might be interested to actually contribute to it, to collaborate on it. So, for example, if you come up with an idea that aligns with, for example, Taiwanese governmental priorities, that it can actually catch the eyes of Taiwan Space Agency, and TASA will be like, this idea is really cool. We haven't thought of it. And it, like, you can connect it with a local government organization or local industry partners. Again, for example, if you have a biology experiment, and if you can work with a local lab that is specifically in Taiwan, like if you want to send Taiwan special rice or algae, and say that we want to see if this can be grown on the moon. if you can partner with that, then as a government, and if you can say that this is a government priority, then TASA would be like, that is a very cool experiment that is specifically Taiwan, and we would like to fund that. That can happen. So that is why we put that criterion in there, because we want to see if you can figure out how to collaborate and have contributions from your local partners.